Welcome you all for day 6 training, and today in session we'll be covering some of the important factors and some of the important concept of design factors, typically for basic part modeling capabilities, where we are going to just brainstorm more feature in terms of how to use draft, how to use pad, how to use fillets, and how to use shell. So this session is predominantly will give you an idea about the importance of the pad, importance of the draft, importance of the shell command, and how to give the stiffener to increase the strength of the component. So let's get into the sessions today. The first thing, let's get into CATIA first and understand the modeling capabilities first. So today's session, I'm getting into the mechanical part design, and I'm going to give you an orientation about what is the importance of this dress-up feature and how it's going to impact your designs, right? So let's get into this one. So I'm going to delete this feature first. So the first thing is that I'm going to give you what is meant by draft and what is the impact and what is the purpose of giving draft. The purpose of giving draft is to increase what is the anyone can able to give me the brief idea why the draft is given? Apti, Anuku, Bhavish, why we need to give draft? What is the purpose of draft? The purpose of draft is to remove from the mold box for moldability purpose, so that when I remove it, it's easy for removal process, number one, along the direction of the molding process. That's the purpose of the draft angle. And if you take any component, be it plastic, be it metal casting, everywhere you have the draft as a factor. So draft is one of the important factors. So let's get into this one. Go for a sketch, and I'm going to click on my pad. You can see this one, position sketch. You can reverse it, the use of this position sketch, and give a reverse of horizontal and just give OK. The moment you give this one, I'm going to get the profile and I'm going to just draw a rectangle. Okay, this is my rectangle. And I'm going to give the dimension for this feature. And I'm going to give this dimension for this feature. Let's give the dimension here as 75. And let's give the dimension here as 150. Give OK, you get it. And for this component, I'm going to give a pad taking into account the dimension of 50 mm. Exactly, Anku. Very good. So now for this component, if it is a plastic component, or what you can see on the specification tree, there is a pad. For this component, I would like to create the draft angle. What is draft? I'm going to create a draft for the selected edges. This is my one of the face. You can see over here the draft angle is 5 degrees. And what are the phases you would like to give draft? You can see over there. These are the phases which I would like to give the draft. So in this case, I would select this face. Then I would like to select this face. Then I would like to select this face, and I would like to select this face. These are my 4 elements which I would like to give a draft. And always, it's very important that you will have a neutral element. The neutral element with which I'm going to deviate, or I'm going to give the draft angle for moldability purpose in the direction of the pulling direction. So in this case, if I select my neutral element as this one, see this is my element which I'm going to select. So neutral element is with reference to this particular plane, I would like to create my draft angle, or else I'm going to clear the selections. I can able to select even this face. So now the pulling direction for me is that much, and the angle what I'm going to give 5 degrees. You can just see over here that 5 degrees is with reference to this particular face, right? The moment you give this 5 degrees, you can see that the draft is given for this component. And if you want to change the direction, you can just go there and change the direction in a reverse direction, so that the draft is given in this direction. Preview it, you can see that the component is subjected to draft, and give OK, you can see that. And you want to change the orientation, just go there and double click on that and change the orientation now, and preview it, you can see this one, the draft is given. So when you see from a top view, just to make you understand what is meant by draft, when you see from the top, you can see that this particular edge is visible for you in terms of draft. Okay, so that means your concept of draft is just to remove the component from the moldability process. This is a simple way to make you understand about the draft. So now moving on, now we know draft simple, we need to give these components. The purpose of draft for plastic component is not much less than 4 degree to 5 degree, maximum is 5 degree. Metal casting, it can go a bit high. So there is a concept where any plastic component, be it any trims of an automotive or interiors of an aircraft, it's made up of plastics, where the draft angle is a must because of its molding capabilities. Until unless you're not giving the molding draft angle, you will have those challenges. Bhavesh, I hope you are very clear. Exactly. So, yeah, Anuk, that's great. So that means most of the time, maximum it could be 5 degree. Or else, as Anku is telling, it could be 3 degree for plastic component. Metal casting could be different. Now, I'm going to give you a little idea about the operation and the feature which you are going to use it. Say, for example, I given a draft, right? And I can use this draft at any position. I'm going to delete this one. And I'm going to tell the impact of draft over the features. Now what we did, we just created a pad. This is my starting feature, base feature. Followed with, I'm going to give fillets. I just give this fillet. See, for example, this one, and this vertical edges, this vertical edges, and this particular vertical edges. These are my 4 vertical edges. Sorry, I selected this element. I'm going to remove this element, this one, remove this one, and I'm going to remove this one as well. I'm going to remove this one as well. This is the first element, this is my second vertical edges, third vertical edge, and fourth vertical edges. So these are my 4 vertical edges which I have given, and I'm just going to give this dimension as 25 mm. Or give, let's say for example 10 mm. I just give this fillets. For the purpose of understandability, I'm just going to increase this width to a little more, to say for example 125, and just exit this one. So now I just given this one more. Okay, and this pad thickness to nearly about 25 mm. Sorry, this pad to thickness of say for example 100 mm. Right, I got this one. That means now I just created my draft for this value, and then created this component. Just a minute please, just a minute please. Sorry, one disturbance. Now this component, if you see this fillet, whatever I have given is given a 20 mm fillets. And now for this sketch, whatever we have created for the sketch, I'm just going to give 50 or something like that. Give OK, fine, you get this one. I just created this draft. Now if I give this draft now, see, this is very important to understand for you people. Now if I give a draft after edge fillet, what is going to happen? See the change. Now the draft is done after edge fillet. So I'm going to select this face, and my neutral element, you know that my neutral element is going to be this face, right? My neutral element is going to be this face, and preview it. What has happened now? See the importance. At any point of time, if your fillets draft or replaced its orientation or the structuring in the specification tree, you can see the diverse changes. That means here my objective was to give fillet of 20 mm, but the moment I gave a draft angle of 5 degree or 10 degree, to make you understand, it has become a variable fillet. See this? You just measure it. I'm going to use measure and tell you that this is my variable fillet. See, at this point it is 20 and here it is different, 28. This is not the meaning, right? That means within 2 commands itself we understood that orientation and ordering of your feature within the specification tree can have an adverse effect of the design changes. So that means the first statement what I would like to tell you is that the moment you create your pad first, then you go for creation of draft. Don't keep. If the design intent tells you that you need to have a fillet of this much, you can go. But this is not the right case. Now what I need to do? I need to replace this one. So I'll just reorder this feature. I'm not going to teach you reorder. Just for an understanding purpose, you are new to the platform. I'm just going to delete it and I'm going to just teach you that this is the right process which you should have it. That means first, always give draft angle. This is one point, this is one phase, this is the second phase, and this is my fourth phase. These are my 4 phases which I selected it, and now I'm going to select this one as my neutral element, and I'm going to give 5 degree for instance, and preview it. You get this one like this. And now if you go and give a fillet, see that I'm just going to give fillet. I'm going to select this fillet, and I'm going to select this one, and I'm going to select this fillet, and I'm going to select this fillet. These are my 4 fillets which I'm going to select for a radius of 25 after giving the draft angle. Then you see that the fillets remain same. So this is the fundamental requirement you should understand. Alright? Pad, draft, edge fillet. That to what? I just made edge fillet vertical edges first. I never used horizontal edges. Now I would like to change the draft angle. See the change? For an example, I'm going to change the draft angle to reverse it. Give OK, you get changes. Now, what I would like to do, I would like to create a fillet at the bottom face. Right? That means I'm going to select this particular face. And I'm going to create fillet at the bottom face. That means I selected my horizontal fillet at the end. That means after vertical edges. So I'm going to give here 10 diameter radius. So now if you understand, my design is within the specification limit, and this is the process which you need to understand. Always remember that when you create a pad, it should follow with a draft, and it should follow with the vertical edges, then it should follow with an horizontal edges. Just to make an understanding, this is my vertical edges, the pink one, and the green one is my horizontal edges, right? So this draft is my brown one. So that means the first, always you remember, this is just for making you understand. I have just given the colors, but practically it is not possible to give different color for different features, but to make you understand. At any point of time, if you reorder any of the feature, right? If you reorder any of the feature, you will have an adverse changes. The design itself get collapsed. That means the first fundamental things you need to understand is that always start with a pad, draft it, then you give it vertical edges, then follow it. So out of this 25 people attending it, I'm setting a standards in the industry that a 26th person who is not at all within this training group, I will tell him that go and change the parameter for horizontal edges. He comes exactly on this one and understand that this is horizontal. Because I set a standard. All the industries, right, be it aerospace, automotive, they set a standards that when you start creating any other feature, create your base feature first, then go for the dresser feature, and then go for a vertical dresser feature, vertical edges, and then go for horizontal edges. At any point of time, you do this in a reverse way. See that changes. I'm just going to give a Control Z, undo, right? I'm just doing Control Z just to make you understand. At any point of time you do reverse way of design, you will have adverse changes. So this is my component, right? After that, if I give horizontal edges first, see this first edge, I have to select all this 4 times. See, I have to select one by one each and every time. Sorry, let it be like this. I'm going to select this one, and this one. I'm just selecting each and every time one. So 4 times I selected this one, and I'm going to give 10 mm. See this? I just gave after draft horizontal edges. Then now if I give vertical edges, see the process. It's a complex process. I've seen so many youngsters doing this sort of mistakes while designing it, right? And then now I'm giving 25. The same process. So that it is taking a problem. The design itself is not happening. So that this is a challenge. So don't even do it. Let me give for understanding purpose a little value. See this is a message. That means this is not at all possible. So the first understanding for you people is always focus vertical edges. It becomes easy. I will tell you what is the reason or what is the logic behind it. The logic behind it is that I'm doing Control Z, undo. The moment you select your horizontal edges, see first this is my vertical edges, this is my second vertical edges, third, and this is my fourth. I just selected it. When I give this 25, it has taken it, right? And it has taken beautifully. And then what I'm going to select, I'm going to select only this one because of its continuity. See that? Because of its tangency continuity. I have not selected 4 edges, I have just selected this one. Because of its tangency continuity, wherever this, because I made this vertical edges fillet first and then made it this value as 10, you get this one. So this is your process. So always remember PDF. What is PDF? You know PDF document. So same way, always remember that when you start designing the process, you remember this terminology called PDF. Pad first, draft first, second, and fillet first. In that fillet also, you take a call that first is vertical edges, and followed with horizontal edges. Like this. So now I am setting a standards. Are you guys there with me? Please let me know. Are you following me? Just message me. Perfect? Great. Right. Thank you very much. So that means here we are making the process set. And these are the fundamental mistakes which we see while interviewing so many freshers. At any point of time I reverse this feature, it is gone. Now not only this, I'm going to add one more component here. I'm going to add one more component called shell. So always remember PDF, yes. The shell should be the last feature after your fillets. So see this. I'm going to select this fillets. So I'm going to change this fillets to a dimension of 5 mm. Just a minute. I just change it. See this. And now what I'm going to do, I'm going to teach you a new command called shell. What is this shell? This shell, the purpose of this shell is to ensure I'm going to take some wall thickness, right? Wall thickness of material 2 mm or 1 mm. Here I'm going to give the dimension of 2 mm. And just give it OK. Now you can see your component is designed, and the fillet which we gave at the bottom, see this fillet which we gave at the bottom is taking care inside as well. What is the shell? Shell, what it does, I'm just going to do once again. It takes the material on the top face. I'm going to select the shell on this top face, and I'm going to give the thickness of this face. The pink color indicates that it's going to dig the material, right? It's going to dig the material. For what thickness? 2 mm. So I'm going to give this value as 2 mm and give it a value. Any point of time you get this to 2 mm at different points. So that means you need to understand that in this case of design, your process of design should have always, don't forget this concept, a very important concept. I will tell P, D, F and S. At any point of time you reverse this order of design, you will have adverse changes. In that also, as I told you, you should have first vertical edges and then horizontal edges. So that's my point. So first is vertical edges, then I would like to have my horizontal edges. At any point of time you do these changes, if you do any changes, you will have an adverse change in the design aspects. I'll tell you how exactly it is going to happen. Right? For example, I'll just delete all this one. Delete all. Give it OK. And this is my sketch. And I'm going to make it isometric. And I'm going to make this pad. And I'm going to make it as 50. Mirror it. Or just 25. Mirror it. This is my component, right? Say for example, to make you understand. Leave out this component doesn't have draft. Leave about this component doesn't have draft. So what you do? I will give fillets first. Say for example, I'm going to give fillet. Which one? Vertical fillets. These are my 4 verticals. I'm just going to give it. Okay, and I'm going to give a radius of 10 mm. You got this one. Then what is the message is that you have to now I'm just telling give a shell. You by mistake you have done this shell for a thickness of 5 mm for example. You got this one. Then what you do after giving shell, observe carefully, I just created pad, then I created edge fillet. After creating this one, what you do, I will create fillet in the bottom. This could be the problem. Most of them they do it. What's that? There is no difference. I created this. What is wrong that I can create next to this one? So I just give, for example, fillet of 5 mm. So you see everything is good, sir, no problem. But the moment you section and see this one, see this. The moment you section in this one on this particular plane, sorry. The moment you section it, I'm going to section exactly on this plane. See what is happening? Obviously your stress concentration will be here and it will fail here automatically. You know that. The design is not meeting the requirement. Your wall thickness is not meeting the requirement. Obviously it will fail. The entire container will fail over a period of time. Or we are in the world of product design where repeatedly changing happens, right? You feel your design is good enough, you have done a good job, but what happens? I just change this value from 5 mm to 10 mm. Your design is gone, your adverse design. See the changes. Are you guys following me? Very important concept which I am telling you. Beat any of the softwares. Beat any of the softwares. You use any XCAD, use it. This is the process. Is it interesting? Is it interesting? You may be knowing this one. Yep. So, but the point of discussion has to be taken care of. At any point of time, this could be the adverse design conditions. That means always remember that this shell should be the last feature, right? This should be the last feature. Just go there, reorder this fillet shell. I'm going to reorder. See that? I'm going to reorder this shell after this edge fillet. Go there. Now you can see that your defined in work object is edge fillet. That means currently edge fillet is visible. You right click on this one, put define in work object for this edge fillet, right? For edge fillet 2. The moment you put it, you can see the bottom. And the moment you see here the shell defined in work object, you can see that. But now you see that the fillet is appearing inside as well. Now you do any changes on these values. You do any changes on these values. 5, sorry, it is already 10. I'm going to change it to 5 value. It's not going to affect. You can see the fillet inside as well. So this is the a very, very important feature which you need to understand, right? So that means always understand, you have a pad, if you have a draft, put it define in work object there. Create a fillet draft there. I want to create a draft where this, cancel it. I'm going to create a draft here. After this pad, you see this, I'm just bringing define in work object, not lost. Put the underscore, define in work object. Select this face, and this face, and this face, and select my neutral element as this one. And preview it, you get this fillets. Put it reverse direction. And give it OK, you get this fillets. And now you put it define work object, this one, you get this fillets. Now you put define in work object, this one, you get this horizontal fillet. Put this define in work object for the shell, you get this one. At any point of time, you will not have any changes. So this is a process which you need to understand when designing. I do these changes. Any fresher, when I interview, I give a tool test. The moment I see the specification tree, I will understand their integrity and knowledge of the design, right? I understand on what basis they will do it. They'll feel they have done the good job, but see this, if they fail in the basic understanding of ordering your specification tree with some of the base features and the dresser features and vertical edges, horizontal edges and shell, the entire design is not meeting the requirement. So that is the fundamental requirement which you need to understand. Okay? Are you guys there with me, please? Thank you very much. It's great. You can mute. Thank you very much. Thank you. So now from here, what is the next I would like to teach you? Okay, fine. We had increased the component. My objective is this component. So for example, this length I'm going to increase by, for example, 250. As engineers, you just tell me what could be the effect of this component box. As engineers, you tell me what could be the effect of this component. And I would like to reduce the thickness for better understanding. I'm just making it as 15 mm, right? Or make it more, no problem. I'm just going to make it as 25. That's okay, fine. So now, what is our objective? When this component is a plastic component where there is a draft and fillet, shell, everything is given, when the subject is placed, what can happen? This strength, if it is whole, if we are placed, if a load is applied, there could be a strength factor coming into the picture, right? There could be a strength factor. You apply a load from here and apply a load from here, what can happen? It can buckle. So what we need, I would like to increase the strength of this component, right? I would like to increase the strength. To increase the strength, what I will do, I'm just making it little bigger for you to understand. Just make this one to 75 so that it is visible for you. Right, this I just made it 75. You can see this now. So my objective is to increase the strength of this component so that I would like to add some stiffener to this component. To add a stiffener to this component, understand, I'm going to create a new feature called stiffener. This is my stiffener. The purpose of the stiffener is to increase the strength of a long cylindrical or a rectangular component, to increase the strength. It could be plastic, it could be metal casting, whatever it is process. But it is a process where I would like to increase it. So the stiffener are of two types. One is from side, one is from top. Stiffener are of two types. One is from side, one is from top. From side, that means I'm going to create a stiffener from side. What we want to create a stiffener is we need to have a planes. That means in this case, I would like to create a stiffener at each and every location. I would like to create a stiffener here, I'd like to create a stiffener here, I'd like to create a stiffener here, right? To increase the strength and in line with the fillet, whatever it is created, right? So let's get into that one. So how to create a fillets. So fillet, for creating the fillets, I would like to have certain planes, reference elements, because you have only one plane, right? This particular plane. So I'm going to create a reference plane. So you know how to, first time you are teaching you how to create this plane, the reference elements. So I just move this one a bit more, and I'm going to keep this one here. And I'm just moving this one here. Okay. So in this case, I'm going to create a plane. Offset to this one's offset to this YZ plane or YZ plane at a distance of, say for example, so 75 mm. I get one. Perfect. And I'm going to create one more at another place, reverse. I'm going to create a plane and I'm going to make it a reverse, one more plane. So that means these are the planes at which I would like to create my stiffener, right? That means what I would like to do, I'm going to create a plane. On this particular plane, I would like to create a sketch. And that sketch is of stiffener type of side, from side. So let's go and create it. So first thing, there are two types of stiffeners, as I told you. I'll just show you that one. If you see the stiffener, from side you are having and from top you are having. From side means it should have a sketch. This is my sketch. I need to create. Both are from top also has a sketch. Now in this case, I'm going to create a sketch, simple sketch. Just click on this plane, observe here, and go for my position sketch. And this is my horizontal, this is my vertical. Give OK, you get this one. So you want to understand, make it fit so that it is centrally fit. And you would like to know whether my section, what I'm going to create is there. So this is my section, see this. Normal view, you can able to normal view it, right? So now what I would like to do on this particular plane, you can see this is my plane, right, which I sectioned it, and you can just see this one, right? On that particular plane, I would like to create my sketch, which is going to increase my strength of this component, plastic component. So I'm just going to draw a line from side. So this is my line from that plane which I just created, and just draw a line on that one, right? And then I'm going to just dimension this line. So I would like to make this point and this line, right click. This is a very easy way of giving constraint. And then I'm going to select this particular point and this particular line, give it constraint. That is also done. And you want to give the fully constraint, so let's go and give the dimension between this one and this one in angle of 50 degree for an example. And I'm going to give the dimension from this particular point to this particular point as well, so you get this one. So I'm going to give this dimension as 25. So this is my stiffener, or you want to reduce it to 15 mm. Yes, you can reduce to 15 mm. Just give it to 15 mm. That means I just created this sketch on that particular plane. Which plane? On that particular plane. You can just see this, right? Now this particular plane, for make you understand, I just give a color code so that you are very clear that this is my plane on which I just created, and this plane, on this particular plane only I just created. This is my green plane on which I just created the sketch. See that, you can see that. Now I'm going to increase the stiffener, right? I'm going to add a stiffener at exactly at this particular point from side. You just see from side and select the sketch. The moment you select the sketch, you zoom this one, you can see that from 1 mm this side, 1 mm that side, I've just created number 1. And what is happening, the material is going towards this direction. See that there arrow, this arrow is pointing towards the material side. See this arrow, it's pointing towards the material side. This is my material side. There is no material other side, right? You can see that there is no material other side. Now if you just create 1 mm thickness or 2 mm thickness, neutral element, that means with reference to the sketch, 2 mm goes this side, 2 mm goes that side. Preview it, you get a total of 2 mm. So see this, right? Neutral element, 2 mm thickness. That means 1 mm this side, the 1 mm other side. That's the point. And give OK, you get the sketch. And that is just stiffener which I created. You got the concept what is stiffener is all about? Folks, you got the concept what is stiffener is all about? Thanks, Blessing. Now, what is the parent child of this particular stiffener? So let's go to this stiffener. Go to and click on parent child relationship. See this, very interesting. Sketch 2 is my parent child. Parent. And what is the parent of the sketch 2? Show this. You can show that. That is my sketch. That's the reason. And which is the parent of the sketch? Edge, pad, shell, edge fillet. Because this stiffener is intact with the pads face, shell face, fillet face, and edge fillet. So this design is good enough. And this is my plane. This is also the plane, which is plane 1, which is taking as a reference. So always have a parent-child relationship while designing it. Fine. So now we have designed it. And I would like to have the same stiffener at this particular point. What should I do now? Go there, click on the sketch. I'm going to click on the sketch and go for position sketch. Same thing. And just see, I'm going to create a sketch on this one and give OK. So now what you would like to have, this sketch, if you see this, it is done on this particular plane. Which plane? The middle plane, YZ plane, right? And I would like to have the same sketch to be used there, right? I would like to use the same sketch to be used there. What I'll do, see that, yesterday I taught you how to use project 3D elements, shell out edges. I'm going to use project your 3D elements. Which edge? I would like to project only this edge onto that plane. Which plane? This plane. See that it gets projected. See this objective. I'm just projecting this particular component to the other end. See this is what I'm going to project. See, Control Z, I will just repeat once again. On this particular plane, I would like to create the sketch. I'll delete it once again. Okay. I'm going to select this plane, go for a sketch on that particular plane, and I would like to use this particular plane, right? And give OK. And want to project. See this, I would like to project the edge of the existing component, onto the surface. Projected it. The moment I projected, you can see that it is got projected. And exit this workbench. You can see the sketch is fully projected on that one. That means this sketch is driven by this edge. Let me go and give fillets once again. So just to make you understand. I can do transformation feature, but I am teaching you what is project 3D elements. I'm going to select here and select this feature and give it OK. Fine. Now the moment you do any changes on this sketch, which we did, right? The sketch. And if you just do any changes, say for example, I would like to change this one to 15 to 20 mm height. The moment I change it, this also gets changed. See this, because I projected that one. So the moment it gets updated, because this sketch is projected. So how to understand that one? Just go there and click on this one, go for parent-child relationship. And see that this stiffener which we created, see the parent is nothing but stiffener edge, and this is done on YZ plane. Just see this parent of this one. The parent of that is sketch. So you can understand that this is how the link of the design happens. Okay. So now the same way you want to have it here, you can use the transformation features. But anyhow, I'm going to teach you how to use the same sketch and get it done. Just go there and use the same edge. I'm going to use the same sketch. Project it, and you can see this one, and just click on the sketch. You can see this is my projected edge. So these are my sketches which are getting projected at different location. And exit this workbench, and you can see here this is my sketch which is got projected. So I'm going to use stiffener from side. So very important, at any point of time, if you have, for instance, you do one more sketch, sir. Can I do the sketch this side also? What you do, you go to the sketch and you try to create one more profile. I will create the same one and make us mirror. You know that how to use a mirror, right? I'm going to put it normal to you, and I would like to create the same stiffener this side also. I would like to have other side also. I use mirror and select this with reference to plane. So you get this one. So now you will tell for the same sketch I would like to use this stiffener. So it never happens. You will have an error. Stiffener should not have open profile. It should have a closed profile. Okay. That means this particular point, when you create a stiffener, you need to have a separate sketch or a closed profile. So this is not possible. So always remember. So people do mistakes. I'll create the same sketch. I will do one more sketch. It's not possible. Right? Sorry guys, there with me? Please let me know. Perfect. Thank you very much. So now what is our objective? Next I'm going to teach you the same fillet. So I'm going to delete this one. And I'm going to teach you fillet from top. I'm going to teach you fillet from top. So for fillet from top means I'm going to just select a plane, and I just see that this plane is at a distance of say for example 20 mm, 15 mm. Give it OK, you get this one. And I'm going to use the sketch. See, I'm going to click on my sketch and top view and give OK. I get a sketch. So in this sketch, you know how to create a constraint sketch, right? I'm just drawing this line. I'm going to draw n number of lines. See this? I'm going to just draw n number of lines. And you know how to constrain the sketches. I'm not constraining here. I'm just going to use one more line. And I'm going to constrain here. And I'm going to constrain here. Right? And go there. I have created only one sketch, a single sketch, which I created a plane which is at a distance of certain dimensions, 15 mm or something, which I give it. Now the same stiffener. From side you understood, from top. Let's go from top. This is a top, which is a sketch I'm going to select. This single sketch, not different sketches. All these lines are single sketches. See the meaning. You'll ask me, Bernard, we have created this sketch, but this sketch is not meeting this endpoint. This sketch is not meeting this endpoint. What is the reason? So no problem. So select it and see that it creates it. It automatically understands that this line meets this one and this extends until this one. At any point of time you put reverse and preview it, it will show you the reverse way of the dimensions. So be careful on the designs. Okay. So let us do in a process where you are going to use a stiffener from top, and I'm going to select this sketch and I'm going to use from top. So I'm going to use from top and just give it OK, you get this one. So this is my stiffener which I created. So at any point of time you want to just reduce this one to a minus value as well. You can just see this. So I'm just creating this value. At any point of time you would like to create it, just create this one. So you can just create this stiffener. So stiffener, you can ask me, stiffener, is it Bernard we need to have only one sketch, a straight sketch? Not required. Should be the sketch linear? Not required. It can be even a curve. I'm just going to create the curve. And exit this one, you get a stiffener of that one curve also. It's possible. What it does, it goes and meets the endpoint. It goes and meets the endpoint. That's a point which you need to understand. Okay. So let's get one example. So what we learned is how to create pad, draft, fillet, vertical fillets, horizontal fillet, shell, and we understood what is the impact of stiffener from side and impact from stiffener from top. And I'm going to share you one of the exercise which you need to practice by yourself. I'm not going to demonstrate. You need to use this feature, understand the drawing, and just demonstrate. I'm going to pump in so much of drawing today so that you can start practicing for tomorrow's session. So, but before that, we close for the day. I'm going to give you one more exercise and give an idea about this, how to start thinking about this. Let's open this model. So in this case, this is my model. The first objective for me is that the base feature. Do I see any base feature? Yes. I'm going to create this pad. So this I'm going to create this pad first. and I'm going to create a pad for 175 mm. Perfect. And I don't have a draft. If at all you would like to give a draft, you can give the draft for all the faces. So I'm going to select here. These are my faces: phase 1, phase 2, phase 3, phase 4, phase 5, phase 6, and phase 7. So these are my phase, and you can select continuity, no problem, takes it. These are my 8 elements which I selected, and my pulling direction is this particular point. That means, what is the meaning of pulling direction? I'm going to pull the component from the dry cavity, right, from this direction, right? Just move this one and give it, preview it, and just going to give this value. Give OK, you get this value. So this is going in this direction. So this, you can get this one. So this is my component which I have draft. So after giving the draft, I would like to give the fillets. So I'm going to select all my sharp edges. So the concept remains same. I'm going to give all my vertical edges. So this is my first vertical edges. This is my second. All I'm going to select is my vertical edges. So I'm going to select this one, and I'm going to select this one. I'm going to select this one. I'm going to select this one as well. These are my vertical edges. So I'm going to give the dimension of the vertical edges as 75 mm. So this I just give it. So the moment I just give the vertical edges, it's easy for me to give horizontal edges. The same concept sold here. See this? Give it. Okay, fine. And I'm going to give 10 mm. Right? I just gave this one. Now I'm going to teach you some very interesting thing. Understand this concept first. Before giving shell and after giving shell, what happens? So in this case, I'm just going to put a hole on this top face. See this? On the top face. Position in sketch. You know how to create a hole, right? And I'm going to make this component show your planes, and I'm going to make this point move this one, and you know how to give the dimension between this point and this particular point is, say for example, 225, and I'm going to make the constraint between this particular point and this particular point. Give it constraint, you get this one, and exit this workbench, you get this hole. For instance, I'm giving a hole of dimension 50 mm. Give it OK, fine. I just give a fillet of 50 mm. So now I'm going to use the same feature other side. So I'm going to use the same mirror and use with reference to this one other side. You get one more. So now if you do shell, what's going to be the result? If I do the shell on the top face, what's going to be the result? Observe here. The moment I select here and give a shell on the top face of thickness 5 mm, just observe what's going to happen. You're going to get a component like this. So now you need to understand the power of shell. So it's going to create this component. Before the shell, if you give the fillet, see the bottom face, see the face bottom, there is no surface. So go there, go and put define in work object. I have not given the shell. See this? The shell is there. I'm going to delete this one. And I'm going to give fillet in the bottom face. Now you see this? I'm going to select fillet bottom and here as well the fillet. And give 10 mm or something like that. I just gave fillet. Now you just see the shell, observe the shell. You can see adverse design conditions. So just same value. See this? You can see this. And bottom side, you can see this. So this is how you should think designing. How the feature is going to play an important role while playing with this different features here and there. See, the same thing if you do after that, it becomes like a cutout. So in this case, you will ask me, Bernard, I would like to create a stiffener over here. You can create. Stiffener is not only for linear line. Just for instance, I'm going to create a plane. I would like to use a stiffener at any point of time. Here at this particular point, I would like to create a stiffener. So just take a point and create a plane and reverse direction. I'm just moving this here. I'm just keeping this one here. Give OK, fine. At the same time, I would like to move my whole position. I'm just going to change my whole position from here to, say for example, 500 or 450. You get this change, perfect, you get this one. And now you are telling Bernard, can I just change this fillet? So I'm going to change this fillet to a little more center position so that you can just see this one, 163 or something. And now I'm going to select this plane and go for a sketch. The moment I go for a sketch, reverse the horizontal and give OK, you get this one. So now if you go and select your section view over there, see this, you can see this section view is coming over there, right? You can see this. And it's not mandatory that always your sketch has to be normal to you. You can just draw a line and constrain it. See, I'm just going to draw a line and constrain it. You can constrain it. It's not mandatory that it should be constrained. So, but the moment you just draw a line and see that this line is appearing over there, and I'm going to create a stiffener at that particular point. And it's going to increase by 10 mm. So your stiffener is created at this location. See this. We're taking into account this count. That means when you start designing your feature, it's very much important that the feature whatever you created is appearing, and the impact of a shell as a last feature also is very important. So better always use stiffener after giving shell, and shell should be a last but one feature after the stiffener, right? So that means, what is the objective of today's session? We learned how to create some of the very important process while designing it. Number one, pad, draft, vertical edges, horizontal edges, then go for hole or things, then finally you can able to give shell. At any point of time you reverse the order or the process of this design, you are going to have an adverse condition of the change of the designs. Number one. Number two, you're going to have some understanding about the stiffeners, right, of this one. If you move this shell, reorder this shell after this stiffener, you just see this, what is going to happen. I just moved it, your shell, now you give it, that could be the case. The stiffener is a challenge, sorry, stiffener is not going to come, okay, so very important. That's a very important factor. So it should be case. Or you would like to change this hole after this shell, it will be, you can't see able to see this projections. So it's very important while designing that you understand the concept of using the feature, and once you understand the feature, you are through with the design process. So this is what the industry expects you in terms of the best design. Thank you very much for the day, and if you have any doubts you can ask for me. Hope the doubts and the clarification is meeting your requirement.